traffic control, an air traffic controller spots two planes flying at the same altitude. Their flight paths form a right angle at a point P. One plane is 150 miles from the point P and is moving at 450 miles per hour. The other plane is 200 miles from point P and is moving at 450 miles per hour. Write the distance s uh, between them as a function of time t. So as we already see, this is a plan here that moving at 450 miles, but it's 200 miles per hour. So let's denote this function here, first of all, with the s1 as is denoted. S1 is equal with the distance. The distance here is 200 miles, and 200 miles, let me write 200, and this distance is a decrease in as a function of the v time t. So the speed, the velocity of the plane as the time goes. As much as the time goes, this distance is going to decrease. Because it's a decreasing, I will write a minus v time t. Because the v is the same, and time we don't know, the time is almost the same time is going to go. So let me write as a constant v time t. And s2 is going to be equal, the distance s2 is 150 miles, but this distance depends on the speed of the plane v, the second plane here, time t. And just for our information, we already have to know the first plane is 450 miles and the other plane is 450 miles. So the v is the same 450 miles. But the distance s, we have to find the distance s between two planes. What is the distance s here? And because of this function, this distance is a right triangle, we can use the Pythagorean theorem that says the distance here, we already see is in the form of the hypotenuse, is equal to the square root of s1 square plus s2 square plus s2 square. And now the distance s, but s we are writing in the terms of the function t. So let me write the s of t, so it looks a little bit more professional. And we can write now the square root. Let me write a little longer this square root. And now instead of the s1, I'm plugging the values of s1. What is the s1? Is a 200 minus, but now instead of a v, I am plugging here the velocity of the first plane, which is 450 miles per hour, 450 time t. So s1 I already am expressing here in terms of the function t, but this is a square. Is a square, and let's go a little bit further. Plus, I'm trying to squeeze this second value. S2, we write it 150 is a minus same thing. The velocity even of this plane is 450 miles. Therefore, I'm writing here 450 time t, and everything is in square. So because here is just what we are doing here, we can simplify. When you simplify everything inside here, you do some algebraic work, this is going to be equal when we are cleaning up the mess and everything, and when we are factorizing, final result is going to be 50. So you can prove it at home. I am not going to do all of this work because it's going to take a long time, and I don't think it's necessary to do this simple steps, is equal with 162 t square, 162 t square, when you clean up everything, t square minus 126t plus 25. So when you plus 25, so when we write the distance between the two planes in the terms of the time t is going to be 50 times square root of 162t squared minus 126t plus 25.